Count the starting reactant molecules in the initial mixture. By examining the particulate diagram of the reactants, there are exactly 4 molecules of H2, represented as pairs of dark spheres, and 4 molecules of O2, represented as pairs of unshaded spheres. Write and balance the chemical equation. The reaction of hydrogen gas and oxygen gas to form water vapor is represented by the balanced equation. 2H2 plus O2 gives 2H2O. This stoichiometric relationship dictates that 2 molecules of H2 react with 1 molecule of O2 to produce 2 molecules of H2O. Identify the limiting reactant. Using the 2:1 stoichiometric ratio, the 4 available molecules of H2 require exactly. For molecules H2 times 1 molecule O2 over 2 molecules H2 is equal to 2 molecules of O2 because we have 4 molecules of O2 in the container, but only 2 are needed to react. Oxygen is in excess. Consequently, H2 is the limiting reactant and will be completely consumed. Calculate the contents of the container after the reaction goes to completion. Water molecules produced. The 4 molecules of limiting H2 will react completely to form exactly 4 molecules of H2O. Excess oxygen molecules remaining. 2 of the 4 original O2 molecules are consumed in the reaction, leaving exactly 2 molecules of unreacted O2 remaining in the vessel. Hydrogen molecules remaining. 0 molecules of H2 remain since it was the limiting reactant. Identify the correct diagram. The particulate diagram representing completion must contain exactly 4 H2O molecules, each shown as 1 unshaded oxygen sphere bonded to 2 dark hydrogen spheres, and 2 intact O2 molecules, each shown as a pair of unshaded oxygen spheres. This matches the arrangement in diagram B, option B. The correct answer is option B. Visual, diagram B.